Welcome, everyone, to the operational and budgetary impacts of the CARB ACF regulation. This is part 4 of a 5-part video series over the state and local government regulation component. My name is David Rentschler. I'm with the City of Fairfield. Mr. Worthington with Santa Clara County is also here. This is in partnership with the Sacramento Clean Cities Coalition, who is helping us put this video series together. East Bay Clean Cities, Silicon Valley Clean Cities, NAFA, and the Municipal Equipment Maintenance Association, MEMA, of both Northern California and Southern California are all partners in this. So some of the topics we're going to talk about today are EV accident damage, vehicle challenges with battery module replacements, capital and budgetary costs, and regulatory language and reference documentation.
So real quick, EV accident damage. This is not as known as people believe as far as accident rates. So as an example, in California, 2022 data, there were 36 million vehicles registered in the state. 425,000 of them were electric vehicles, which represents 1% of all the vehicles registered in the state of California. Vehicle fire data suggests that you have a 1 in 1,500 chance of a vehicle catching fire in the United States, whether it be gasoline, diesel, propane, hydrogen, or electric vehicles. Data from Europe suggests that the Tesla EV models have a 1 in 20,000 chance of catching fire in Europe. But the reality is, with less than 1% of the vehicles in California registered as EVs, is there's really not enough data to indicate what the fire risk is for electric vehicles compared to any other type of fueled vehicle. A single EV fire can need as much as 40,000 gallons of water to extinguish it. The water is mainly used to cool the battery packs down and put out the fires that are created from other components in the vehicle catching fire, such as carpets, headliners, trim panels, seats, things like that. The EV fires can trigger a hazmat response based on the materials that are flushed out with the water onto the ground, and if it's close to a storm drain or a creek nearby. And those costs may be billed to you after everything's cleaned up, and the costs vary from $5,000 to $20,000. You may need a dedicated containment system necessary to store damaged EVs as a safety precaution. We'll have a couple examples in the slides coming up on what those look like. And very simple accident damage may require a battery module box replacement, effectively totaling the vehicle. And an example of that is undercarriage damage. We often in fleets find vehicles that are driven off-road, driven over curbs, driven over rocks or other material, which damages the undercarriage of the body and or frame. Well, with most EVs, the undercarriage is actually the battery pack itself as a skateboard design. So anytime you run over a curb, hit a rock, hit some other debris in the road, it may damage that battery pack. And there are instances where insurance companies, or for the safety of the operators of the vehicles, the battery packs are replaced because they're damaged and you can't see inside to see if the batteries themselves are damaged. First responders. Typically, we think of first responders as police and fire, but the reality in fleets is it goes beyond that. It goes to tow truck drivers and your own fleet staff. In many cities in California, unless there are injuries, gasoline or fluid leaks from the vehicles in an accident, or they are blocking a major thoroughfare, the police or fire dispatchers will direct the vehicle drivers or owners to exchange contact information, insurance information, driver's license information, and then call a tow company and remove the vehicles from the accident scene. The challenge here is in regards to damage to the battery modules or battery packs that most people can't see. Completely different challenge than a gasoline or diesel vehicle, where typically if the fuel tanks are ruptured, you're going to see fluid on the ground, or if it catches fire, you'll see the fire right away. EV fires can start 48 hours to 2 weeks after the battery modules have been damaged. And again, it's based on the fact that most EVs use a skateboard design where the battery packs are mounted low in the chassis between frame rails or just below frame rails. And again, you need to be aware that the damage to those battery packs can result in a thermal runaway event that creates a fire anywhere from 48 hours to 2 weeks after the damage occurs to the battery pack. Here's some examples of EV battery fires from around the world. The top three pictures are from a transit bus, and it wasn't actually the bus electric battery that caught fire. It was a EV scooter that was taken on board, and the EV scooter's battery went into a thermal runaway event, got up to temperatures around 1400 degrees, which then caught seats and other trim panels nearby on fire. What's interesting is the third picture to the right is of the actual hybrid battery pack mounted in the roof of this bus, which remained intact and did not catch fire or go into a thermal runaway event. Most EV trucks and buses need to be stored farther apart to prevent one bus or vehicle from catching fire next to another one. Again, the temperatures on a thermal runaway event from the batteries can reach as high as 1400 degrees. Doesn't take much at that temperature to catch other objects on fire next to them. The picture at the lower left is exactly that. First bus caught on fire, which caught the next one on fire, and then started the third bus on fire because there wasn't enough distance in the parked vehicles. The middle picture is from a transit bus with a hybrid battery pack on the roof, or I'm sorry, full electric battery pack on the roof that caught fire. They ran out of water and then started putting foam onto the battery pack, which really doesn't cool down the battery pack, and the battery pack continues to go into a thermal runaway event. And then the bottom far right picture is of transit buses that caught fire inside a facility and damaged the facility to the point that it would need a major remodel, if not actually torn down and replaced. Light-duty EVs currently, the manufacturers require a 50-foot radius between the vehicle and the next closest object in case of a fire, or if it has been damaged, to make sure that if a fire does occur, it doesn't catch anything nearby on fire as well. Our medium and heavy-duty truck electric vehicles may require much greater diameter or radius around the vehicles. And again, the fires can develop 48 hours to 2 weeks after the battery packs are damaged. This is a picture of our fleet maintenance facility. The red circles show that we do not have space on that facility at all for a single EV containment radius, and we're having to look at other sites in order to contain the EVs until we're sure that they're not going to catch on fire. A majority of the towing vendors do not have space to meet these requirements. If you visit your towing vendors and look, they try to maximize the amount of space that they use, minimize their overall cost for storage. A lot of those facilities are leased, and when the vehicles are parked so close together, they present an additional risk for an EV catching other vehicles in the tow yards on fire. This is another facility. Again, the red circle represents where we wouldn't be able to have a 50-foot radius around a light duty or a car. And then the green circles are areas that we are proposing to create as containment zones where we can park up to 2 vehicles at any given time for between 48 hours and 2 weeks. The surface areas around these green circles are gravel. We're going to level those. We're going to ensure that there's a containment berm for any water that is used to cool down vehicles that are on fire, to prevent the water and runoff from going into local drains and or creeks. Currently, EV accident repair damage data that's available suggests that the cost to repair an EV are anywhere from 27 to 43% higher than conventional vehicles. If you are using an insurance company to cover your fleet, it is very common for insurance companies to total out vehicles that have damaged battery packs because they do not want the risk of having those battery packs repaired or the damage inside of them not going noticed, and then the vehicles catch on fire and catch other objects nearby on fire. These are some containment system examples from Europe where they used to contain EV fires. Basically, they're putting the vehicles into a metal container and then flooding the container with water to cool down the battery packs and slow down or prevent thermal runaway. There's different ways of loading the vehicles. On the top right picture, it shows that they're using a crane to physically load the vehicles into a containment bin. There are other designs where the end of the containment bin is a ramp and you push the vehicles in, or both ends have a ramp and you actually use a cable and tow the vehicle into the containment system, close the ends, open up the roof and start flooding that containment system with water. And just to state the obvious, the vehicle is a total loss when this happens.
So let's talk a little bit about upfitting. Some of the limitations, trim level package can be a problem, especially with vehicles like the Ford Lightning. The Lightning Pro does have some upfitting that Ford allows. However, the higher trim level you go, the less the upfitter guide says that you can do with the vehicle. Can you add additional pieces? Well, you're going to have to run ground wire. Can they be grounded to the frame or not? What type of amperage restrictions, and can you put a second 12-volt battery in the truck or not? How about where the electrical equipment can be connected to that 12-volt system? The auxiliary batteries, where can you mount equipment? Can you drill through floors? Can you drill through other panels in the vehicle and be able to mount things? And then what happens when the 12-volt battery gets discharged? Um, some of these electric vehicles, are they going to turn into the brick mode like your phone does? And then does the vehicle need to be towed on dollies only, or flatbed, or how can it be towed? Next. So self-contained auxiliary power units. We've got a couple of pictured here. How do you charge them? One of the things we're doing in areas of the corporation yard where we think we're going to be parking and charging some of the public works trucks that'll have these auxiliary battery powered hydraulic and air compressors and so forth on board. We're running extra conduit for 110 volt so that we can have an extra outlet at each charger that we're going to plug this stuff in and charge overnight. And then is it compatible with the actual truck chassis, and where's it going to mount? So frame rails, having clean frame rails on the outside is extremely important when you're trying to build a utility bed. A lot of the EVs that are out there right now have components related to the EV system that are hung on the outside of the frames. So can those now go into a compartment, or do you need to have compartments instead of, halfway, the bottom of the compartment being halfway at the rear wheel? Now it's above the rear wheel because it's above the frame. Now your compartments are much taller off the ground. Next. So let's talk about the battery modules. People keep saying battery prices are going down. Well, not sure if that's true or not. I have an example here where it's not true. And then our module is going to be backwards compatible. So we have some diesel electric hybrid buses here, and those buses, the batteries require a refresh at 6 years. We were told that was going to cost $25,000 when we bought the buses. They also told us if at 12 years, if we keep the bus, we need to replace the battery module completely, and that we should expect $50,000 for that cost. So in the two examples here, same style bus, same year of bus, uh, and the one on the left had a battery go bad after 3 years. It was out of warranty, so we had to pay for it to be replaced, and it was $44,500. The one on the right is at 12 years. We replaced battery, and it was $82,365. The battery price did not go down; it went up. It almost doubled. So that's something you need to think about. Next.
So the capital costs can be quite high for transitioning to all electric medium and heavy duty trucks. Currently, the ZEV trucks that are available in the marketplace, which are limited to the low hanging fruit, which is your class 2B through 3, and then your class 8, which are tractor trailers that are running up and down highways with 53-foot trailers. Those costs vary between 1.5 and 5 times more expensive than conventional gasoline or diesel powered trucks. The cost on class of vehicle and duty cycles can be very high, depending on, again, the class and duty cycles, body designs. The vehicles themselves can cost anywhere from a low end range of $90,000 to $1 million each. There is a limited amount of cost data available, but as an example, a 3-day, 3-axle day cab diesel engine truck with a frame modified for a lowboy trailer. The quote from June of 2014, or cost from June of 2014, was $114,000. To replace that with another diesel truck in 2023 is $175,000. But to replace that same truck with a ZEV in 2023 is $569,000, which is 3.25 times more than the diesel-powered alternative. And the dealership is not positive the frame can be modified for a lowboy trailer. So this truck actually may become even more expensive if a different chassis or truck manufacturer needs to be chosen that produces a ZEV that can be modified or set up for a lowboy trailer operations. You may also need to purchase additional vehicles because the available designs can't meet your current duty cycles or towing requirements. This is especially important when you have take-home vehicles because the commute mileage from the place of your operational area to the employee's home and back is going to decrease the range and operating capacity of the battery pack should they be called out on an emergency. So you may need to have 2 vehicles, one vehicle to go to certain types of incidents and another placed in a different location that you drive to and drive that to the events because it's got a larger battery and it's fully charged. The charging infrastructure costs vary greatly depending on locations, how far the charging port is going to be from a facility that's supplying the power, or if it's a separate service for that area. They vary anywhere on average from $35,000 to $200,000 per station. Again, it varies widely. And then you've got additional charging infrastructure needs for the auxiliary equipment, such as what Mr. Rentschler talked about. Having battery packs mounted on the chassis to power cranes, generators, compressors, aerial units, welders, hydraulic pumps. We are finding that most manufacturers have not stated if you'll be able to tie into the battery that moves the vehicle to power this auxiliary equipment. So you need to plan for the potential need for additional battery packs on the chassis to power the additional equipment. Mobile recharging vehicles or trailers for remote work sites or public safety power shutoffs, they can cost up to $1.3 million to support 2 or 3 very large trucks, ZEV trucks. Then we've got facility electrical capacity upgrades just to support the refueling of EVs. They can vary from as low as $5,000 to more than $65,000. And here are some examples of the charging stations costs, and they vary greatly depending on if you have dumb chargers, which are you get no data from, whether they're 110 or level 2, which is 220 volt, or when you get up into smart chargers that provide you data and control over your network, and then all the way up to the DC chargers, which are referred to as fast chargers, which require a lot more amperage and voltage. But the station hardware costs can vary from $1,500 to $140,000 or more. The installation costs on average can be anywhere from $10,000 to $195,000. And then beyond those two costs, you've got additional costs beyond the hardware and infrastructure installation. You have anywhere from $500 to $56,000 when you start including in cellular costs, software costs, service plan costs, hardware warranty plan costs, fleet management information system software integrations, and it goes on and on and on. It all depends on what your vehicle design is and what infrastructure you need to recharge them. Facilities. If you have or lease facilities, that creates a new challenge and potentially higher costs on lease rates, because if you're going to go in and install charging infrastructure to support vehicles that are parked at that facility, the landlord may or may not be open to the idea of the charging stations, or they may want to open up and amend an existing contract or an agreement to increase your lease rates of that facility for either them to install the infrastructure or to allow you to install the infrastructure. And then you also need to be aware of how long you plan on being in the facility, have agreements in place of what's going to happen to the infrastructure installed. If you leave the facility, does the landlord take ownership of that, or do you remove it and return the facility to its condition prior to the installation? It's very, very complicated with leased facilities compared to owned facilities. Then the human resources costs. You may need new facility positions to manage the charging station infrastructure, the repairs, the maintenance, resetting stations because of power outages where the stations don't automatically power back up and start distributing electricity through charge sessions to the vehicles again. And then you've also got to be researching, applying for grants, rebates, and vouchers and other funding sources to help offset the cost of the infrastructure. Then you may have new fleet positions. You may need new job classifications just to do all the research, specification development, and regulatory compliance. Our vehicle specifications are going to change radically for ZEV vehicles. A lot of the data that we already have and specs that we already use, it won't be so much a cut and paste as it will be brand new specifications that you've got to develop. Different body designs, different locations for the battery, auxiliary battery packs. There's just quite a bit of work that needs to be done in regards to ZEVs. And then we've got the whole administrative workload of the ACF regulation for applying for extensions, exemptions, doing the research and collecting all the data for these extensions and exemptions, and then tracking all the data and reporting it to CARB through their website on an annual basis. We're probably going to need new fleet job classifications, mainly because of the high voltage safety disconnect, arc flash training and certifications that are required in working on these medium and heavy duty ZEVs. We also need to have training performed on specific manufacturers and models because each manufacturer designs and operates their high voltage system slightly different than any other manufacturer. Our technicians and our mechanics need to be very well aware of how those systems work, especially from the safety aspect. Then you're also going to need to update job classifications because now we're going to be doing different types of maintenance and repair work. And again, if we've got a high voltage system, large battery packs, large amperages, all staff, whether they're working on the high voltage systems or batteries still need to be aware of contact release safety training and the dangers of arc flash. Then we need to, again, update facility job classifications for the maintenance of the charging stations, the repair of them. They also need to be aware and have certifications in high voltage safety disconnect and arc flash training, contact release training, and then specific training related to the charging station manufacturers. If you have more than one charging station manufacturer or model design, you may need to train multiple people to be aware of how each of those designs works, functions, and can be repaired. Then we've got what will probably come from all these changes, which is pay scale increases, which means we need to open up negotiations with unions, bargaining units on pay scale increases. We're going to initially have a lack of a talent pool that we can draw from when we're recruiting for these positions. So there aren't very many technicians that have the skill sets that we need for ZEBs currently. We're all competing for a limited talent pool, and that talent pool is already stretched thin across the nation. So you may need to look at phasing in of the positions over time as more and more people become trained and knowledgeable about the systems and vehicles, or you may need to start training everybody internally and working through a phase into the positions that way. Then we've got costs related to our procurement departments, the collection, tracking, and management of the vendor certifications that they are in compliance with the ACF regulation, acquiring attestation documents that the regulation doesn't apply to the vendors that you contract with, tracking all of that, public works project costs. The contractors, general contractors, are going to be doing the same type of paperwork and have the same type of administrative workload we have, but at a greater scale because they're dealing with subcontractors and subcontractors of the subcontractors and then rental vehicle agencies. So we expect them to pass on those costs to government agencies. So we're going to see higher costs related to public infrastructure projects.
So as we have in the other series, we provide regulatory language and reference documentation. So we highly encourage that you go to these websites listed on the screen and you check out the actual Advanced Clean Fleet regulation. So for more information, please sign up at the link provided for to be on CARB's listserv, and that way they'll send you emails for new updates to the regulation.
I'd like to thank the Clean Cities coalitions that supported us in the development of this webinar series, specifically Sacramento Clean Cities, East Bay Clean Cities, Long Beach, and Silicon Valley Clean Cities. Also like to thank NAFA and MEMA. We are not the only ones that collected all the information and data that we're sharing through these webinars and this video series. There's a lot of fleet managers and staff throughout the state that have helped in collecting all this information so we could provide it to you. So again, please support these coalitions and fleet associations. They're doing a great job in dealing with this regulation and all the changes that we need to implement in the future. We will have a final part 5 of this video series that we'll be releasing. And thank you again to Mr. Rentschler. Here's his contact information as well as my contact information should you have any questions. Again, thank you for your time, and we look forward to the next video series, part 5.